By now, in this course, we learned how to name things properly and to not overuse comments. We haven't worked too much on the actual code which we write, except for the names we assign to things. Now, therefore, in this course section, we are going to take a closer look at functions, because functions ultimately are where we write the majority of our code. Functions or methods. And in this course section, you will learn how to write clean functions. And we'll have a look at every aspect of functions. We'll have a look at the parameters, the arguments you use in functions, and how to be clean there. And of course, we're going to have a look at the function body, and we're going to talk about the length of functions, abstraction levels, and how to properly split one function into multiple functions to increase readability. And as always, we're going to do this with a bunch of examples, demos, and also a challenge for you. So let's dive in. In order to write clean code in functions, it is important that we reflect on what makes up a function. And for that, we should probably look at a function. For example, this dummy example add function here. And just as a side note, when I say function, and what I show throughout this module will also always apply to methods, since methods are really just functions inside of an object. So this is a function or method, and of course we cannot just define this function and write the code for this function, we can also call this function, which could look something like this. And when we talk about clean code, both parts should be clean. Calling the function should be readable and also easy for us as a developer. If we are calling a function, we want to have an easy time doing so. For example, the argument order should be clear. And of course, working with the function, writing code in an existing function, maintaining existing functions should also be easy. So the function body, the definition of a function, should also be readable. So therefore, it's the number and order of arguments which matters to us, because that defines how easy and readable it is to call a function. And it's the length of the function body, the amount of code we have inside of a function, which matters. And in this section, we are going to have a look at both aspects. Now, let's start with the left side here, with calling a function and with passing values for function parameters. And here, for writing clean code and for being able to call functions in a clean and understandable way, there is one simple rule. You should minimize the number of parameters your functions use. Because the more parameters a function uses, the harder it gets to call them. And harder here really means that it's harder to memorize which value should be passed as which argument, so the order of arguments can be confusing. And if you have to pass in a lot of arguments, it also simply is a lot of code to write, and ultimately that all leads to more code you have to read, more things you have to keep in mind. We can probably all agree that calling a function or method with no parameters is very simple. If we, for example, have a user object, and on that user object we have a save method, then this is very easy to call and to read. We don't have to pass in multiple values and remember the order of arguments. We don't have to do anything of that. We have one function call with no parameters. This, therefore, is very easy to understand. So it's easy to understand and easy to call. And therefore, this is the best possible way of calling a function, though of course I will say right away, this is not always the way you can do it. There are of course functions or methods which do require parameters. You can't refactor every function to take no parameters. That will just not be an option. Nonetheless, sometimes you can achieve this, and if you can, this therefore is the best possible option when it comes to ease of calling and to understanding this code. Still very good is if you need one parameter, one argument. For example, if you had a log function which takes the message as the one argument it wants. This is still very easy to understand and still very easy to call. You have to pass in one value, there is no order which you have to memorize, and if you read this code, it's crystal clear what it does. So this is still a very good option you can use. Now it already becomes a bit more tricky if you have two arguments, two parameters which need to be passed in. For example, if we have a point object which we can instantiate by calling its constructor, which this code could do, where we then pass in two arguments, let's say the x and y coordinate of that point. This is still okay to understand because it is kind of common sense that probably the x value is the first argument and the y value is the second argument, but still there is some ordering which you need to keep in mind. The order could be switched and therefore this is acceptable to call, but you might have to think about it for a second to quickly verify that the first value really is the x value and the second value is the y value. So therefore you should use this approach or write functions with more than one argument with caution. In some cases, like here for a point, it is still absolutely fine because it is quite obvious that the first value will be the x value and the second value will be the y value. But for other functions, this might not be as clear. And then it immediately becomes harder to call them because you have to think about the order of arguments. And reading that code, therefore, also could become harder because it's not immediately obvious which argument fulfills which purpose. Now, if we have even more arguments, let's say 3 arguments, then we reach the point where it's very hard to justify why we need that many arguments. For example, if we have a calc function which calculates something, we might take in the 2 numbers which we want to use in the calculation, and then we have a third parameter which defines which kind of calculation we want to perform. And this is challenging to understand and challenging to call. If we read this, it is still okay if we have add as a type, but if we have subtract, it's already not 100% clear which number gets subtracted from which other number. But especially when we call this, it's also hard to understand because the order is totally not obvious. We will probably need to dive into the code or use some IDE features to understand which argument should go where. For example, the type of calculation, add in this example, could also be the first argument. Common sense doesn't tell us whether it should be the last or the first argument because this is not a common function, not a common thing, unlike the point. So therefore you want to avoid functions like this if possible. There can always be scenarios where you need a function like this, but you will probably not have them as often as the other scenarios on the left here for non-1 and 2 arguments. Now, any functions with more than 3 arguments should absolutely be avoided. For example, if you had a quartz function which takes 4 values, this would be very difficult to understand and to read and very difficult to call. It's not obvious at all which value describes which coordinate or what this function really does or wants. So you really always want to avoid having functions with more than 3 arguments. Nonetheless, I could imagine that you now automatically have a couple of examples in mind where you think, well, but I need more than 2 pieces of data or more than 3 pieces of data. So let's now have a look at a couple of examples and a couple of solutions for functions which need more than 3 pieces of data. Now here are a couple of examples. And let's start with this example where I have a save user function which takes an email and a password, so 2 parameters, and where we then create a user object on the fly. This is all written in JavaScript, by the way. And in this object, I save the email and the password, I also add a randomly generated new ID, which is not a perfect unique ID by the way, but good enough for this example. And then we reach out to some database as it seems. We could have also named this database, of course, and insert this user into a user's table or collection. Now, don't get me wrong, this function is absolutely not horrible, and if you have code like this, it's not the end of the world. Still, if you call this function, it would look something like this. And you probably would have to take a closer look at the function to understand that it wants an email address and a password, and that the email should be the first and the password should be the second argument. Again, not the end of the world, and definitely also not totally unexpected. Still, when we write code like this, we might be able to come up with a better solution. For example, we could come up with a function like this, which only takes one argument, which is the already finished user. So we would outsource this task of creating the user out of this function into another place in code. So obviously this only works if we construct a user ahead of time, but then we have a simpler save user function, which ultimately of course also is very easy to call. Still, it takes one argument, but now I would say it's easier to understand and call, and it doesn't leave us guessing whether email or password should be first and which kind of values this function might want. Now, an even better solution could be this one here. Here we have a class user, which acts as a blueprint for new user objects, which then has a save method which can be called without any arguments. Therefore, user.save is very easy to read and very clear and understandable. And instead, we now outsourced the problem of passing in values for the email address and the password to the user constructor function. And there you could argue it's a bit more expected and obvious than on a save user function. As I mentioned, that also wasn't horrible, but this code might make even more sense and might be even easier to understand. And therefore, this acts as an example of how you could transform code to be easier to understand and to not use any arguments on certain parts of your code where arguments might not be obvious and the order could be unclear. I also got one other example of a function that takes no arguments, and that would be this one here. Let's say we have a isLoggedIn state which we manage somewhere, and then we have a function which just changes that state. Therefore, this function does something, but it simply needs no arguments for that. It just inverts this isLoggedIn state all the time. So that would be another example of a function without any arguments, because in this case it doesn't need any. So these are some examples, and again, I want to emphasize that this original solution still isn't horrible, but maybe the other solutions we derived make more sense or improve readability even more. Now let's next have a look at a couple of examples for one-argument functions. For example, here I have a log function which simply wraps the built-in console log method. Now we can argue whether such a function makes too much sense, but we could be doing that if we want the option of quickly swapping console log for some other outputting or logging mechanism. Then having our own logging function, which we use throughout our program, could make sense, because if we ever switch from console log to some other mechanism, we only need to make that switch in one place instead of in multiple places. And then we have a function where it makes a lot of sense that we need one argument and just one argument, and that would be the message which should be logged. Now we could also come up with a way of writing this such that no arguments are needed, again by creating a class which takes the message in the constructor and then has a no parameter log method, but I'm not too sure whether this really is an improvement. It's a lot of extra code, and we just replace a function where it was totally obvious that we might have a parameter and where the kind and value of that parameter also is no surprise at all. So here I'm absolutely not a fan of changing this just for the sake of changing it. Instead, I think the original example with one argument here makes a lot of sense and is absolutely something we can keep around. Now, here are more functions where one argument makes a lot of sense and is totally obvious. For example, this square function, which simply squares a number and therefore takes that number as a single parameter. Or the email is valid function, which takes the email address which should be validated as an input. These are all examples for functions which we can leave like that, and where having one argument is totally fine, obvious, easy to read, and easy to understand. Now, what about functions that take two arguments? For example, take this login function here. It takes an email and a password, and then internally it might be doing whatever logic is required to log a user in, to create a session for the user, for example. This again is something which makes sense and which is expected. Here we have two parameters, but the order is not surprising because in most forms we also have the email field first and the password field second. So this order of arguments makes sense. And calling this function is very readable. It's immediately obvious what this function does and that we have an email address and a password as expected parameters. So this could be an example for a two-argument function, which is no problem at all. Another example would be this point class, which we instantiate by using the point constructor. We take two arguments here, the x and the y coordinate, and this again is really just common sense. It is expected that the x argument is the first argument and the y value is the second parameter, and therefore this is easy to understand, easy to read, and does nothing unexpected. We don't need to think a lot about calling this constructor function here because it is very obvious what it does and what these values will be. So, as you can probably tell by now, it is about minimizing the number of parameters, but it's simply also about how readable and how easy to understand a function is. If it's obvious which parameters it needs and in which order these parameters need to be provided, like in this login or point example, then it's absolutely fine to use two parameters. You don't need to come up with a way of reducing the number of parameters. Because after all, you should always keep in mind that writing clean code is about writing readable and meaningful code and about reducing the cognitive load. So if we have no cognitive load, because it's clear and easy to grasp what a function does and how we should call it, then of course there is no need to rewrite it. And that is an important difference between the examples I showed you thus far and this example here. Here we got a log function which actually takes two arguments. And if you just have a look at the way we call this function, it's totally not obvious how we should call it, what this second argument is about, and which order these arguments should have. It's obvious that we have a message, but what does false mean here? We need help from the IDE to get some extra insight, but ultimately we probably need to dive into the code to fully understand what this actually does, and to understand that isError is an extra flag which controls how the message is being output. And you want to avoid such Boolean flags in general, but in addition, this is also a good example for a two-argument function which would better be written in a different way, or which would better be refactored. For example, here, a better solution could be to split this one function into two functions, where one function is dedicated to normal messages and one function focuses on errors. That way we have two functions with one argument each, which then again are way easier to call and understand. And that is what clean code is all about. Questioning the code you have and trying to always improve it such that it's more readable, easier to understand, and requires less thinking and reasoning about the code. Now we will dive into the functions which are a bit harder to understand. For example, this example. We have a user class with a constructor function where we assign name, age, and email. Now, this can be instantiated like this. And if we read this code, it is kind of obvious that it's the name, the age, and the email address. If we write this code, however, our IDE will definitely give us some help, so it's not too hard to fill this out, but it is not 100% obvious in general that the name field will be the first argument, then the age, and then the email address. This is not something we can take for granted. It would not be unexpected if the email field would be first. And therefore it's not too hard to call this because of this IDE support, but it might be even better if we don't need that IDE support like this at all, if we don't constantly have to look at which value goes where. And therefore, to actually improve the readability and usability of this function, which a constructor function still is in the end, we could rewrite this example like this. Here we have our user class still, but now it doesn't take 3 arguments in the constructor, but just 1. But that 1 argument is a simple data container, an object or a map, which has various fields, which we then use to extract the values for name, age, and email. But now the advantage is that when we call this function, when we instantiate this class down here, we just pass in such a object here in JavaScript, a hash map or a dictionary in other languages, and the order does now totally not matter. It doesn't matter if we have name, email, age here or email, age, name, because we now extract the values by identifier name, by key in the end, like we're doing it here. So now we don't have to worry about the order anymore. And if we see this code, it's also even more readable. It's now 100% obvious that Max is the name and not, for example, just the first name, which is something we could have thought with this first example here. It's not clear whether that is the username, the full name, or the first name. Here it's clear it's the name in general, so the username probably. And therefore, this is how we could replace multiple parameters with 1 parameter by simply using an object or a map as that 1 parameter. That allows us to technically still feed in more than 1 value, but in a more structured way. And this is therefore your go-to solution if you have a function which needs multiple pieces of data, which is totally normal, but where at the same time you don't want to have an endless or unstructured list of arguments. Then you can simply refactor this to just use 1 argument, which then in turn is a structured data container, like a map or an object. Here's a similar example. I have this compare function, which takes 2 values and then the comparator argument, which in the end defines which kind of comparison is made. And again, this is very hard to call. It's not obvious whether that comparator should be the first or the last value, and hence this function could also be rewritten like this. Now it takes just 1 argument, which again is such an object or map of key value pairs, where it's now much easier to identify what the first and second value is and which kind of comparison operation is being performed. And again, the order does not matter here. We could also have comparator here as a first key value pair because it's all in the same single argument. It's just a map, an object here, where this data is grouped together, and in there the order does not matter at all because we extract the values by key anyways. So that is how we could avoid having functions with 3 or more arguments, because whilst 3 arguments can be acceptable in rare cases, it's almost always the case that rewriting it like this is way easier to grasp and understand. Now, when it comes to the number of parameters, there is one special case, one special scenario, and that would be functions like this. A sum up function, which simply sums up all the values we pass in. We can have functions like this, and even though this function takes 6 parameters, 6 arguments in this case, I would argue that it's very easy to read and understand. It's very clear what this function does, and the order does actually not matter here even for this example. Still, technically, we violate the rule of having less than or equal to 3 parameters. Here we have 6. Now, of course, we could rewrite this function, also internally of course, to take an array as an argument. then we technically have only one argument because this is one array. Please note the square brackets. We could do this, and this could be a perfectly viable solution, but we don't even have to do that. So here I'll comment it out so that we still have it for reference. Otherwise, of course, we learned that we shouldn't comment out things, but simply delete them. Nonetheless, here I'm doing it so that we still have this alternative solution for comparison, but I still want to make a point that this way of doing it also can be absolutely fine, because most programming languages allow you to take in a dynamic number of arguments, and they then have a certain syntax for grouping all these arguments together into an array inside of that function. For example, here in JavaScript, it's this free dot operator here, which simply tells JavaScript that numbers can be any number of parameters, any number of values, but that they will all be merged together into one array. Which is why then we can simply loop through that array to do something with the values in there. And that allows us to define a function which technically takes more than one parameter and more than 3 parameters even, but which still is very readable and internally simply uses an array. And I would argue that functions like this also are pretty clean, because ultimately we must not forget that clean code is not about hard rules which you have to follow under all circumstances, but that it's about writing code which is understandable, easy to read, and easy to maintain. And this code is perfectly easy to read and maintain, hence there is nothing wrong with it. Now the number of parameters matter, but in addition, it's also the kind of parameters. And there's one specific kind of parameter which you absolutely want to avoid, and that would be the output parameter. Now you should try to avoid output parameters or output arguments, especially if they are unexpected. And I have this second part here because in some cases, especially when working with certain third-party libraries or frameworks, you can't avoid them. But they should never be unexpected. Take this as an example. We have a function which is named createID and which takes a user. Now let's assume that this function internally then adds an ID field to that user object which it receives as an input. And that would be not great, because then the user, which is passed into the function, gets modified by the function. So the function doesn't return the ID for the user, which was passed in. Instead, it manipulates the user object which it received. Here's the full example in code. It's a createID function, and internally it manipulates the value which it receives and adds an ID field with a certain value. So if we pass user to createID, it simply will have that ID thereafter. And this is not necessarily obvious. We might not expect the user to be edited. We might have expected that we can simply call createID and get back an ID which we store in a constant. But that's not what this function is doing, and therefore this is not really clean code. It has an output parameter because it actually outputs the result of its work, in this case generating the ID, as part of the parameter which it received. It manipulates the parameter instead of returning a new value. You generally want to avoid this, and you especially want to avoid having functions which don't sound like they're doing what they are doing. It might be better if your function would be named addID instead of createID. So let's say it still does what it does internally, but now the name addID makes it more obvious that it adds an ID to the user which we pass in. It doesn't just create an ID, where we then could reasonably expect that the ID is returned, but instead addID makes it very obvious that the user is likely to be edited. Hence here we still have an output parameter, but at least it's more expected, so it would be okay. It still might be even cleaner to not use output parameters in the first place, but if you can't do it any other way, then at least make it obvious that you do have an output parameter. Now, an even cleaner solution, by the way, might be to use an object-oriented approach where you have a user object on which you call addID without any arguments. Then this would be very obvious that this probably edits the existing user, and here it would therefore not be unexpected. After all, here we don't even have a parameter, so we definitely also don't have an output parameter here, because there is no parameter at all. So this function is totally understandable and doesn't do any strange things. Here's a full pseudo example in code. We have the user class with the addID method, and here we don't have any unexpected behavior. Instead, here it's pretty clear what this method does to the customer object here. And therefore, long story short, the best case is to avoid output arguments if possible, but if you need them, do it as we showed it here in the middle with a clearly named function, and avoid having function names which don't make it clear what you're doing inside of the function, because output parameters can be super confusing and lead to bugs. I mean, after all, you are editing a value which was passed into a function, and that's generally not something you expect from a function. Now that we had an extensive look at the function parameters and arguments, let's have a closer look at the function body. Because when we talk about clean functions and writing clean functions, obviously the function body is an important part of that. We want to write functions where the body of functions, which makes up the majority of the function code, is written in a clean way. And how do we ensure that our function body, so the code inside of a function, is clean? Well, functions should be small. They should be really small, because if a function is small, it's easier to read and understand than if it's big, if it contains a lot of code. Consider this example here. You also find this file attached to this lecture. This is one function with quite a lot of code inside of it. Now pause the video at this point and take a moment to understand, or to try to understand, what this function does, or to at least get an idea of what this function could do. It's again, of course, just a snippet, it's just a dummy example, but it does fulfill a real purpose. So take a moment to pause and find out what this function does. Were you successful? Did you find out what this function is doing? Or do you at least have a rough idea of what this function is doing? It's certainly not impossible to find out, but it will take you a couple of moments, right? You will definitely not look at this function and instantly see what it does in detail. Now I can tell you what this function does. It's a dummy function that could render some HTML content. And for this, it first of all checks the input and ensures that no script element is being rendered. And if it is, then we throw an error. Thereafter, the HTML tags are constructed by building an opening and a closing tag, and the opening tag is actually constructed by also adding any attributes which should be added on that HTML element. And then it constructs a template where opening and closing tag are combined with the actual content of that element, so the part between the tags. And then that template is in the end attached to some root element, which we get as a parameter. And this root element therefore actually is kind of an output parameter here, but let's ignore this for a moment here, because of course there can be scenarios where this is acceptable. And in general, this function here uses good naming, good formatting, that's all fine. And still it's not clean, because it takes quite some time to understand what's going on. Now here's an alternative version of that function. Now many parts of that function code were outsourced into separate functions, and therefore the main function, render content, is pretty lean. And if I would tell you to understand what this function does, you would probably be able to understand this way quicker than with the example I gave you before, even though the function produces the same result. But by splitting the code into multiple, more focused functions, this main function is easier to understand. And also all these extracted functions on their own will be quite easy to understand. It's pretty easy to see, and it doesn't take long to understand, that when render content is called, we validate the element type, because the function is even called like that. Then we create the renderable content, so the content which should be output, and then we render that on some root element with the render on root function. Now, as I mentioned, this code was split across multiple functions, and this can look intimidating, because it overall grew, of course. But each of these functions is quite straightforward and easy to understand, and the idea of writing clean code is precisely that you don't have to read all the related code. If I need to look just at render content, I typically don't need to dive into all these outsourced functions, so I might not even see all that other code. And therefore, if I just consider render content, that is way easier to understand than at the example before. And even if I do need to dive into the individual functions thereafter, all these functions are also written such that they are quite focused and straightforward and should be relatively easy to understand. And that's why clean functions should be small, and we achieve this by splitting functions into multiple functions. Now, one question you might be asking yourself now is, how did I decide what to outsource and which code to put into separate functions? And here we have a simple rule. To write small functions, we should write functions that do exactly one thing. But of course, that brings up a new question. What is one thing? Because if we have a look at this refactored example, it's easy to argue that this function is doing more than one thing. It's validating the element type, creating renderable content, and rendering this on a root element. You could argue that these are 3 things and not just one thing. Now, of course, in programming, it's quite common that we have functions that kick off multiple operations. The goal is not to write functions where every function has just one line of code. That's unrealistic and also not helpful. You don't want to clutter your code with millions of functions. Instead, one thing is defined slightly different. When we talk about functions doing one thing, we could think about the different operations a function is doing, like validating and saving user input, for example. And then we could argue that we have 2 operations. And that's of course similar to the actual example I showed you a second ago. But we don't look at the different operations. Instead, we combine the idea of doing one thing with the concept of levels of abstraction. This concept of looking at the levels of abstraction of the operations inside of a function, this concept helps us decide when to split a function into multiple functions. Here's an example. Email includes and save user. If we have a look at these 2 code snippets, then email includes is a pretty low-level API operation on a string. In JavaScript, it's a built-in method which we can call on strings to check if a string contains a certain character or text. Save user, on the other hand, is pretty high level. It's a developer-defined function for saving a user. We're not using some low-level built-in API here. That's what levels of abstraction are about. We got high and low levels of abstraction and a broad bandwidth in between. And high-level operations would be operations where we just call some function or method which has a descriptive name and then does something. Now, a low-level operation, on the other hand, really dives into the low-level API methods or operations a certain programming language or framework offers. In the case of isEmail, this higher-level operation here, we don't control how the email is validated. We don't know what is actually going on in there. We just want the email to be validated. We're just interested in the result. Now, with the low-level example, we do control how the email is validated. This is the concrete code which decides whether something is valid or not. But the interesting thing is that with the low-level example, it's not even clear that we're talking about email validation. Includes is a method we can call on any string. We, as a developer, add extra meaning by interpreting the result. If I call includes on an email, sure, I want to validate whether that is an email, but that's some extra meaning I, as a developer, add to this operation. It's not obvious by the operation or the method name itself. Includes is a name which does not imply any meaning other than that a string includes a certain character. Is email, on the other hand, is easy to read and there is no room for interpretation. If I call a function called isEmail, it's clear that I want to find out if something is an email or not. I want to get back true or false here. Now for includes at, it's technically clear that it checks for the existence of an at symbol in some string, but the interpretation that this means that an email address is valid is something which must be added by the reader. That's why this is lower level. We have to add the meaning to that. For higher level operations, the meaning is baked into the operation, so to say. So that's the general difference between higher level and lower level operations. In one case, you just know the result, you just know which task should be executed. In the low level case, you know the actual work that's being done, and it's your job to understand why this work is being done and what the goal of that is. Now, the message here is not that you should write high-level code only. Low-level code can also be quite understandable if you write it in the right place. And that's what we're going to dive in next. Why exactly do these levels of abstraction matter, and when should you write which code? I introduced this concept of levels of abstraction in the last lecture because levels of abstraction allow us to decide whether a function does one thing or if it does multiple things. Because functions should only do work that's one level of abstraction below the level of abstraction implied by their function name. Okay, that's a complex sentence. What does it mean? Consider this example. If you have a function which is called email is valid, and it takes an email as a parameter, then you might have some low-level code in there, as you can tell in this example. But this operation is one level below the function name implied level. Email is valid, if we would call this function, is pretty high level, but it's clear that as a result, we want to know whether an email is valid or not. So inside of that email is valid function, we perform an operation on a lower level of abstraction. In this case, email includes at. But writing this low-level code here is no problem because understanding it is quite easy because of the function name of the function in which we write it. The function is named email is valid, so it's clear that we're doing this low-level work to get an answer to this question. So because the operation we do inside of the function is close to the level of abstraction implied by the function name, because it answers the question posed by the function name, we could say, because of that it's easy to understand even though it's low-level code. So low-level code is not bad, it's necessary, you need to write it somewhere, but you should write it in places where interpretation is added by the name of the function in which that low-level code runs. Now, on the other hand, if you have a look at this example here, then you see that this could be harder to interpret. This function is called saveUser, and having this low-level code in there is a bit more difficult. Because here, the function name, saveUser, does not add any interpretation to the low-level code. We have to figure out as a developer that this low-level code is probably executed to validate some input. It makes sense that we have a validation step as part of saving a user, but the actual low-level code is a bit harder to interpret than if it's close to the level of abstraction implied by the function name, as we have it on the left side here. If a function is called saveUser, it should just orchestrate all the steps that are required to save a user. So here we got a too big gap between the level of abstraction implied by the function name and the level of abstraction of the actual operation we do in this function. And I know that this can sound super overwhelming and confusing. It is something that comes with experience and where just thinking about it is already worth a lot. Now, levels of abstraction also matter because of one other concept. And I will also come back to that example I showed you in the last lecture again, no worries. But here's that other concept where levels of abstraction also matter. You should try not to mix multiple levels of abstraction in one and the same function. Here's an example. In this code here, we're mixing different levels of abstraction. We got this quite low-level email includes code and the higher-level user save code. If we read this snippet, we need to add quite a lot of interpretation to it to fully understand what's going on. If this would be written like this, all the operations would be on the same level of abstraction, and it would be easier to understand this. If you read that, you really just need to read the names of these functions, assuming that they are properly named, and you fully understand what this code does. This is why levels of abstraction matter, and why mixing different levels or having a too big gap between a function name and the operations done, why that can cause problems and lead to bad code. And if we come back to the example from before, then the original function suffered from multiple problems. Most importantly, the gap between the level of abstraction implied by the function name, render content, and the levels of abstraction of the actual operations we're doing here was too big. We got a bunch of low-level operations in there, like comparing the element or concatenating our opening tags down there. In the clean function example, that's not the case. We got operations which are one level below the level of abstraction implied by render content here. Validate element type, create renderable content, render on root. It makes sense that these are the steps we need to go through to render some content to the screen. So if we call render content, it makes sense that these are steps that need to be executed. The actual work which needs to be done, the lower level operations, are then outsourced into other functions. And in the functions to which we outsource them, they then again make sense. In validate element type, it makes sense that we do comparisons like this. Here, this low-level code is absolutely okay. And that's why levels of abstraction matter and how you can ensure that you write clean functions. Now, as I mentioned before, this is a challenging and difficult concept. It is something which comes with experience, and even after years of development, you will still sometimes write functions which are not clean. As always, it's also not a hard rule. If you have a very short function with mixed levels of abstraction, that could be fine if it's easy to understand. Nonetheless, it is important to always think about that and to at least consider splitting a function. And we're going to have a demo and a challenge in the next lecture where we practice this at a simpler example, and we're also going to learn about a couple of other related concepts throughout the rest of this module. Now, in the last lecture, I talked about these levels of abstraction, and maybe it's already clear, at least to a certain extent, how exactly that's all meant to work and how that helps you. But it can also be intimidating. You might not be sure whether you can always determine if there are mixed levels of abstraction or not. Now, that's no problem though. Of course, for one, that is also something that comes with experience, and it already is a good first step if you think about your code and you at least consider splitting it, even if you then make the wrong decision. I mean, what is the wrong decision anyways? It's your code, and you are trying your best to make it as readable as possible. But in addition, I also got a rule of thumb for you, or actually 2 rules of thumb, which help you decide whether to split your code or not. You want to split a function, or at least consider breaking up a function into multiple functions, if you can extract code, multiple lines of code, that work on the same functionality. For example, if you have a function which calls both setAge and setName, you could consider merging this into one function, a new function, or a new method in this case, which you outsource from that function in which it was originally. So that in the original function, you now only have to call one other function, which then does the actual work of setting an age and a name. So whenever you have an opportunity like this to remove a block of code from one function and put it into another function, you could consider doing that. The other rule of thumb which I have for you is that you want to extract code that requires more interpretation than the surrounding code. And that again is directly related to these levels of abstraction. If we have a look at this good old example here, then we can easily see that this email includes check requires more interpretation from our side than having a look at save new user. There it's directly obvious what this does and why we're doing this. For email includes, we have to add the extra meaning of email validation being done here. So changing it to this code would bring it all back onto the same level of abstraction and on the same level of required interpretation, you could say. Because now we can easily read this code and the interpretation is all baked into the names. So you can also just have a look at these rules when it comes to deciding whether you want to split or not. Now, up to this point, I showed you a lot of theory and I talked about different levels of abstraction, and I did show you some examples on the slides, but now it's time for a real code demo to make sure that this is all really crystal clear. Here we have a function createUser, which takes an email and a password, and we could also refactor this to take just one parameter with an email and password field in a map, for example, but I'm actually happy with the number of parameters. Instead, it's the function body on which I want to focus here. And we see this is obviously not a super long function, and reading and understanding it probably won't take you too long. Still, it can be faster, I would argue. Because we are doing a couple of different things here, we are doing more than one thing, and we have different levels of abstraction. We have all this low-level validation code up here, we have the low-level error output code, but then we have the higher-level insert call on some database object. We don't write the SQL query on our own here, for example. That would be lower level, and we're not doing that. So we definitely have mixed levels of abstraction here. And in addition to these mixed levels of abstraction, we also clearly have a too big distance between the name of the function, createUser, and the actual work we're doing in there. This low-level validation code, where we check for an @ symbol in the email, that error message console log statement here, that is all too far away from the name createUser. If we read this code, we have to think about the code to come up with an interpretation. It's not obvious by the name of the function that checking for a @ sign means that we're validating. We at least have to think about that for a second. The same for this console log statement. It's not obvious that we're showing an error message here. This is only clear if we have a look at the surrounding code as well. It's not enough to just have a look at the function name. Hence, the distance is too big. And if we would consider our rules of thumb here, both rules would apply. For one, we got multiple validation steps, which we could extract, so that left side applies. We have multiple lines of code or multiple parts in the code which deal with the same operation or with a related operation. Also down there for creating a user and then saving that user. That's also kind of related, you could argue. And in addition, we got code that requires more interpretation than surrounding code. This entire validation error handling part, as I just explained, requires more interpretation than this code down there. Especially calling insert on a database object requires very little interpretation because it is pretty clear what it does. It requires definitely less thinking from our side than this validation code at the beginning of this function. Hence, we got multiple strong signs that we should refactor and split this function to make it cleaner. So how could we rewrite this function now? Well, let's do it together step by step. And of course, feel free to try this on your own first. You can pause the video and try coming up with multiple functions instead of this one single function, which work together such that all the functions are very readable. Here's your chance to pause the video and try this on your own. Thereafter, we're going to do it together. So, were you successful? Let's refactor this together. Now, we have these different levels of abstraction, so I think one obvious first step would be that we remove this validation logic from this createUser function. We can cut it and add a new function below createUser to have this readable top to bottom flow we learned about, and name this input is not valid, for example. And we take the email and the password here and simply return the result of the check which we cut. And then here we call if input is not valid for email and password, And therefore, we have a very readable createUser function. This now reads smoothly. If input is not valid for the email and password, then we console log this and return. Otherwise, if we didn't return, this code executes. So now this function is already more readable just because we added this new function here. And if you don't like the negative wording here, you could of course also name this input is valid and reverse this check whether email is truthy and the email includes an @ symbol and we do have a password, and trimming the password and checking that trimmed password with that is not equal to an empty string. Then this would be valid, and then here we could call input is valid and check for the opposite here. So if not input is valid for email and password, then we do this. But that's just a wording thing. The main thing is that we extracted our logic and moved it into a different function. Hence, this level of abstraction is now in its own function, where we now have one equal level of abstraction. This code here is all on the same level of abstraction, and hence here we actually still have some mixed levels, but at least the input validation is now on a kind of similar level as this code down there. So it is an improvement. It's not the last improvement we can make though. For one, there will be more extraction possibilities in this code, but even if we have a look at input is valid, we could argue that we are doing more than one operation here. We could argue that we are doing 4 operations. We check whether the email address is truthy, we check whether it includes an @ symbol, whether the password exists, and if it exists, whether it is not empty. So we are doing 4 things down there, but we are doing them on the same level of abstraction, and hence we could leave it like this. Therefore, let's focus on the rest of this createUser function. There, we still have other levels of abstraction in there. For example, logging this error here. This is a low-level operation using the built-in console log functionality which JavaScript offers both in Node.js as well as in the browser. Therefore, we could outsource this as well and add a new function, showError, or showErrorMessage, for example, where we take the message as an argument and where we then console log the message. An advantage of creating this separate function also would be that we could use it in different places of our program if we need to show errors in different places. And if we ever decide that console log is not the mechanism we want to continue with, we can easily use a different error logging mechanism, and we only need to change it in one place, in this function, instead of in multiple places. So that's another reason why creating a separate function here might make sense. And now here, we could simply call showErrorMessage, which again is on a higher level than console logging. Now, what about the code down there? This is definitely on a higher level than our validation checks here or console log, but we could argue it's not on the same high level as this code. But this is also something you can always argue about. But we could, for example, create a new function which we name saveUser, where we take an email and password as an argument, and where we then take this code and move it into this function. Though we could argue whether the creation of the object should really be in this function. Alternatively, we could take the finished user as an argument here and just do the database insertion. Here I'm doing both, but again, this is something we could argue about. And in general, when it comes to writing clean code, even though we have a couple of rules and concepts we can take into account, it always will also come down to a certain amount of personal preference, and it will leave room for discussion. Nonetheless, here we could now call saveUser and forward the email and password here, and therefore this createUser function is definitely way more readable than before. Now this function as we have it here could still be split up even more though, because you could argue that all these operations, all these lines of codes we have in createUser are still not necessarily on the same level of abstraction, and also not all exactly one level below the function name implied level of abstraction. Save user probably is, that should be fine. It makes sense that as part of creating a user, we save a user, but this entire validation overall makes sense, but the individual steps which are involved are actually on a lower level. Checking the input validity and showing an error message, that is not necessarily the same level of abstraction as just calling save user. Therefore, we could argue that we want one extra function which we extract. The, let's say, validate input function, where we take the email and the password as a parameter, and where we then in the end run this code here, so that we can call validate input here and forward email and password instead of doing these steps in createUser. Of course, we can't just replace it like this though, because returning here in validate input will not return in createUser and will therefore not cancel the rest of this function. So therefore, we could, for example, switch and not show the error message here and return, because we could also argue that showing the error message is not necessarily something we want to do directly in validate input, because there we should really just validate. But instead we could throw an error here. We could throw a new error where we have our invalid input message as an error message. This is how we could do this in JavaScript. There is a built-in error object which we can instantiate and then throw with the throw keyword. And if we do that, this error would bubble up, would therefore also reach this function, and if it's not handled here, it would cancel this function and bubble up even further. And now it would be somewhere above this function, so where we call createUser, where we should handle this error, and where we then should call show error message. And that indeed is a code structure that might make sense and that would be the cleanest possible code here. So for example, depending on which kind of application we are building, we could have a handle create user request function somewhere in our project code where we do call create user, and we therefore here handle this error and show this error message. And this might be the cleanest way of writing this all. Because now if we go back to the original createUser function, we see that we only have two operations in there which are on the same level of abstraction and which both belong to createUser and are one level below the level of abstraction implied by createUser. It makes sense that as part of creating a user, we validate the input and we then save the user. And hence this is the final form of this function, which I would call clean. Obviously, these were a lot of refactorings, and we did extract quite a lot of functions as part of that, but that is what writing clean code is all about in the end. Now, besides the levels of abstraction and the different kinds of operations you might be doing in a function, there is another reason for why you might want to split a function into smaller pieces. And that would be reusability, because reusability matters, at least sometimes. In programming, whenever you write any code, there is one very important rule, which you should try to follow as often as possible. In the best case, of course, you should always follow it. And that rule is that you shouldn't repeat yourself. Don't repeat yourself. Write dry code. That's something you will hear a lot, and dry code simply means code where you don't repeat yourself. And this is not a complex concept at all. It simply means don't write the same code or very similar code in more than one place. Because if you do, you are repeating yourself. And what's the problem with repeating yourself? Well, whenever you need to change something about that code, some logic or some error, then you need to make this change in multiple places throughout your application if you did repeat yourself. If you never repeated yourself, then you only need to make the change once, which is of course way better. Now here are some signs for code which is not dry, so where you are repeating yourself. One obvious sign, of course, is that you find yourself copy and pasting code. If you're doing that, you are obviously repeating yourself. But another sign would be that you do need to change something and you see that you need to apply basically the same change in different places in your code base. Well, the reason for that probably is that you did repeat yourself. Now here's an example where we do repeat ourselves. By the way, don't wonder why the createUser function looks different than the final function form we derived before. I will simply dive into errors and handling errors in the next course section. Therefore, I again removed that code, which would have been the perfect final code though, just to make this clear. And I went back to this second best solution here, where we actually have more levels of abstraction inside of createUser. But that's not the function we're going to focus on anyways. This createSupportChannel function is new. It's a dummy function which doesn't actually do a lot, but it does one important thing. It takes an email address, because with that we then, for example, create a new support channel where customers can contact us, whatever, and this email needs to be validated before anything is done with it. This, of course, should sound familiar. We did already validate an email when we created a user in the createUser function up there. Here we got this input is valid validation function where we do also validate the email together with the password. So in the end we have some duplication here. It's not exactly the same code because down there we check for the positive case and here we check for the negative case, but it's the same goal in the end. And that's important. Code duplication and repeating yourself does not mean that it's always the exact same code, but that it's the same task you're doing, the same logic you have. And here it's definitely the same. By the way, also for the error message, we're logging an error message here. Well, we did this in createUser as well. There we then just created this showErrorMessage function, which we are calling. Now, because we created this showErrorMessage function, we can at least get rid of this console log duplication. Because if we ever would decide that we don't want to log errors to the console but handle differently, we would have to make this change down there in showErrorMessage, and if we don't use this function here, we would have to make this change here as well. That's exactly why we don't want to repeat ourselves. So here we can of course also use showErrorMessage instead of calling console log, and we already improved this code. But what about the email validation? Well, the fact that we need to validate an email here as well, but not a password, could be another reason for splitting up this code even further. Without the new createSupportChannel function, there wasn't really a strong reason for splitting input is valid into multiple sub-functions. But with the existence of this new function, there is a strong reason. Because now we could add a new function, email is valid, which takes just an email address, which in the end returns this part here. And in input is valid here, we could then just call email is valid and forward the email and combine that with our password checks. And now that we have this extra function, this email is valid function, we could use this here in the createSupportChannel function as well. Like this. Of course, here we need to add an exclamation mark now. And with that, we refactored this code to extract it into a separate function, and we did create this function not because we needed to, because input is valid was unreadable or had mixed levels of abstraction. No, but we did it because of reusability and to stay dry. And this can be another reason for extracting functions and for splitting up functions, because now we don't repeat ourselves. And that's something we indeed want to avoid. Now, as a side note, because I did create this separate email is valid function, and in input is valid we use this function combined with this code, we actually do have mixed levels of abstraction again in input is valid. Email is valid is a higher level of abstraction because that's not the actual work we're doing. Instead, it's just calling some other function, this function, which will do the work. But then we combine this with code where we do actual low-level work. Therefore, here we could consider, and we should strongly consider, to create another function, which is the password is valid function maybe, which takes a password and which then does this password validation, so that we cut this code and return the result of this code here in password is valid, and then here we just call password is valid and forward this password. And with that here, we would again have the same levels of abstraction, and hence input is valid is now clean again. So that's just another side note and a consequence of extracting this extra email is valid function, which we did in order to stay dry. Now, with all the splitting up we did, and with all the reasons we have or we might have for splitting up a function and shrinking functions, there's one important thing though. You should still always use your common sense. You should still always question whether it's now really improving readability and maintainability if you split a function. You should split your functions reasonably, at least that is my opinion. You learned all these different rules and concepts, like the level of abstraction and these rules of thumb and that you should stay dry, but just blindly following all these rules bears the danger of becoming too granular. And just because you are granular and you split your code won't automatically improve readability of your code. Indeed, the opposite might be the case. So make reasonable decisions and don't split your code if you are, for example, just renaming the operation which you extracted. Don't split if finding the code which you extracted will then actually take longer than if you would have just left it in place, because we need to scroll to that new function or search for it. And a good sign for that you shouldn't split is if you have problems coming up with a name for the new extracted function. If you feel like any name you give it is clashing with the name of the function you extracted the code from, then extracting the code might have been a bad idea. And I got an example for this as well. Consider this save user function here. You could definitely argue that we have mixed levels of abstraction here. Having this user object, which I create like this, is on a different level of abstraction than calling insert on this database object. So you could split this and add a new function which you could name build user. This takes an email and a password and then returns this object here. So I cut this object and return it here. And then here I just call build user and forward the email and the password. So that saving a user now is a combination of building a user and inserting a user, which is, I would argue, on the same level of abstraction again. So this is a split we could make. It's not horrible, but in my personal opinion, it doesn't really help with readability too much. It doesn't really improve the code. Indeed, I would argue that we can check two of these free indicators at the bottom of this slide. In the end, we just renamed the operation. Previously, we created a new object, which was a user object, as was clearly indicated by that name of this variable. Because we used proper naming there, it was easy to understand what this object is about. Now I outsourced this code into a function called buildUser. So in the end, that's just renaming the operation, which was obvious before as well, without too much thinking. In addition, it is quite difficult to come up with a good name for this new function. I named it buildUser. Now you could argue that createUser would be better, But this actually clashes with this function, which we have at the very top. Now you could of course argue that this function should maybe be renamed, and maybe you could do that. But still, I am struggling with coming up with a good name down there. Build user, create user, in the end these are just synonyms. And it is difficult to come up with a good name here because we are just renaming the operation. So this split here is one which you can make, which is not horrible, but which I would argue will not really improve readability. And if you do this a lot, you actually might have less readability and less clean code than if you don't do it. And of course, with experience, you'll get a better feeling for when to split and when not to split. In general, of course, all the rules and guidelines and ideas I covered throughout this section still apply though, as you can tell by all the examples you find in the rest of this code file. Now, if you would want to split this code and not have mixed levels of abstraction in save user, you could, for example, come up with a better solution where you utilize a new user class, let's say, which takes an email and password constructor, where you then store email and password. And this again, of course, is a JavaScript example, but you could apply this concept in any programming language. And then you could have a save method here in this user class, in which you call database insert this, or you restructure the data which should be inserted inside of this method. And with such a class being added, you could rewrite this down there to simply create a user by calling new user and forwarding the email and the password. And then on that user, you could simply call save. Now this would be on the same level of extraction in the end. It would be one level below the save user function name. And now we actually did improve the code, because now we didn't just make a useless code extraction or code replacement, but instead we restructured the logic and we changed the place where we manage the user data and the database insertion. That's now all being done in this user class. So if you would want to refactor save user, this could be the better approach than using this extra function which we created before. Of course, now in theory, you could also move further towards an object-oriented approach, and you could add your validation logic inside of this class as well. But that would then be more a question of your general architecture and where you want to have which code. It's then only related to clean code to a certain extent. I just wanted to bring this up here to show you that this can also be a way of refactoring this so that you don't have to make a split which might not make too much sense. By now we learned a lot about keeping our list of function parameters short and concise and keeping the function body short and concise. Now there is another aspect of writing clean functions which you should keep in mind. And that is that you should try to keep your functions pure. Now what does this mean though? What is a pure function? A pure function is simply a function which for the same inputs generates the same output. So for the same input parameter values, you always get back the same output. And this here would be a simple example, this generate ID function. It takes a username as a parameter, it then combines that with a hard-coded string, and then it returns this ID string which was generated. Now as you can see, if you have a look at this code, for the same username value, like max, we will always get back exactly the same return value. This is a function which is 100% predictable and which therefore is pure. Now here's the same function again, now however defined as an impure function. This function, unlike the first one, does not always yield the same result for the same input, because we do generate a random number which we convert to a string, which we then combine with the entered input value. So for the same input value, we will always get a different output value here. Hence, this function is not pure. Now, it's not necessarily bad to have impure functions in your code and in your program, because sometimes you just need something like this. Sometimes you might need to generate a random ID and return that. So it's not the case that impure functions are always bad, but they are definitely less predictable than pure functions, and hence you should only go for impure functions if you really need that behavior. And that's especially true if we don't just consider the generation of a random value as part of your function, but if we specifically have a look at another concept, side effects. Pure functions shouldn't have side effects, which again does not mean that you are not allowed to have side effects at all, but a pure function wouldn't have a side effect, and therefore you might want to minimize the number of functions that do have side effects. Especially when following a functional programming approach. If you're really trying to strictly follow such an approach, it is quite common and expected that the vast majority of your functions, which you compose and combine together, are side effect free and pure. And then you would only have a couple of places in your code where you do have side effects. Now, of course, you don't have to follow the functional programming approach. You could have an object-oriented approach or kind of a mixed approach, an imperative way of writing code, and therefore you don't always have to be that strict. But in general, as you will also see over the next minutes, side effects are definitely something you should be aware of when you write clean code. But for that, let's first of all clarify what actually is a side effect. Well, here's a simple example snippet. This createUser function does what the name implies. It creates a user by instantiating a user object by using the constructor, and then it returns the user. So like this, it would be a pure function. It will always give us the same kind of user object whenever we run this function. However, let's now say we have this line of code in the function as well. This start session line of code. Now, this function, which we call here, is very likely to change the overall state of our program. And that's what we call a side effect. It's an operation which does not just act on the function inputs and change the function output, but which instead changes the overall system or program state. For example, start session could change some variable outside of this createUser function. And when you have such a side effect, a function is also not considered to be pure, because even if it does always return the same value for the same input, if it does something else in addition to the work it does on the inputs, then it's also not considered to be pure. So a pure function is only pure if it always gives us the same output for the same input and it doesn't have any side effects. But what's the problem with such side effects? Again, you won't be able to always avoid them. Indeed, depending on the kind of program you're writing, you might need a lot of side effects, because there are a lot of potential side effects. Starting sessions, sending HTTP requests, even logging something to the console or showing some message to the user would all be a side effect, because it's a change to the state of your system and of your program, right? I mean, if you show something to the user, that's definitely a different state your program is in than a second ago when you didn't show a message. So these changes are everywhere, and side effects are everywhere. But side effects do become a problem if they are unexpected. They're not automatically bad, we need them. But if your side effect is unexpected, then it is a problem. For example, in this createUser function, you could kind of expect a side effect. Maybe createUser implies that the user is also stored in a database, and that would also be a side effect. Starting a session could also be a kind of expected side effect. So in this example, it might not be a bad side effect at all. But consider this example here. It's again the generateID function, but now it's not just generating and returning an ID, it's also assigning that generated ID to some global state, to some global variable which we have in this program. This is a side effect because it's not just work we do on the input and output of this function, it is work we do on some other variable in our program. Now maybe we need to keep track of that last assigned ID. Maybe that is some internal work we do, but maybe it's also not something we expect when we call a function named generateID. Maybe a simple change in the name to generate unused ID would suffice here though to make it clear that this function will need to check whether an ID has been used or not, and that therefore it might also interact with the global system state. So that could be one possible fix here, instead of just keeping the name generateID like this. Because that is the strategy for avoiding unexpected side effects. As I said, and I really want to emphasize this, side effects are not necessarily bad, but your naming matters. Side effects do become bad if they are unexpected. And therefore the name of a function should signal or imply that a side effect is likely to occur. Otherwise, it's considered a bad side effect and therefore not clean code, because clean code doesn't do unexpected stuff. Clean code is, well, clean, easy to read and easy to understand. And if something happens which you didn't expect, you clearly did not understand the code, hence the code wasn't clean. So have a look at these example names here, for example. If you see functions named like this, where would you expect a side effect? In save user, we do expect one, I would argue, because save user implies that this user is probably going to get saved to a database, and saving data to a database definitely is a side effect because it does manipulate the overall system and program state. After all, we write a new entry to a database, we change files. This is a crystal clear side effect. And we do expect such a side effect for a function named saveUser. On the other hand, if we had a function named isValid, then we do not expect any side effects there. We do expect that this function maybe answers the question whether some input or some email address is valid. It would be very much unexpected that this function then sends a message, writes to the file system, shows a message to the user, or changes any other program state. Now what about showMessage? showMessage, per definition, will have a side effect. If we show a message to the user, no matter if that's the terminal or console, or if that is an overlay on a website, if we show a message to the user, we are definitely changing the program state, because the state will be a different one if we have an overlay on the page than it was a second ago when the overlay was not there. So here, because of that name, a side effect would be expected. Now what about createUser? Here, I would say you could go either way. You could say that you don't expect a side effect because a function named createUser will probably do just that, create a new user. On the other hand, create is a very wide word with a lot of interpretation you can put into it. Create could mean that saving that user to the database is part of the creation process, or that validation of the inputs and showing an error message is part of the creation process. So here, it really comes down to the overall context of the application in which you use this function. A side effect is not necessarily expected, I would say, but it's also not totally unexpected. And over the last lectures, we indeed had a function named createUser, which did have various side effects. And therefore, long story short, the idea is simple. It is okay to have impure functions, and it is okay to have side effects. But whenever a function is impure, typically because it does have a side effect, that should at least be expected. Your functions should not have unexpected side effects. And if you have a side effect, or if you need a side effect, you should therefore either choose a function name which implies that, then it's absolutely fine. Or you should move that side effect operation into a different function where it again is expected. This is important to ensure that you have clean code and clean functions, because it's definitely not clean code if your functions do something which is not expected. Now we learned about side effects and pure functions. Let's now have a look at a couple of examples here so that you really get a feeling for what a side effect is and how you could mitigate it. So here's a code file, which you, as always, find attached. And this code file contains 3 example functions. Now, as so many code files, you won't be able to really execute this file. It's not doing anything. It just has a couple of example code snippets. And now I want you to pause the video and have a look at these different examples here. And then try to identify all the side effects you can find. Just add a comment next to them or write them down on a piece of paper. And also think whether that side effect is expected or not. And if it's not expected, how you could potentially avoid it and work around it or make it expected. So take that chance to pause the video and do that. Thereafter, we'll walk through that together. Were you successful? Let's take a look. And let's start with connect database. If we call a function named connect database, we do expect that a database connection is established. This, of course, would be a side effect. It changes the overall system and program state. It's an important difference whether our program is connected to a database or not, after all. So therefore, we would expect a side effect in such a function, and indeed, we do have one. Actually, we have 2, but let's start with the first one. This is the first one. Calling database connect is probably the code that would really establish a connection to some database. So this is the code which ultimately will change something in our system, and therefore this operation will definitely be a side effect. And again, it's not an unexpected side effect at all, so there's nothing wrong with calling this function here. However, we do have a second side effect here. Did you spot that side effect? Well, in the end, it's this console log statement down there, where we output whether we were able to connect or not. Now, this is also a side effect because showing a message to the user is a change to the system state. Now the question is whether it's okay to have this code here or not. And you can definitely discuss this. We do have a name, connect database, which implies that a side effect will happen. But it's this first side effect which we expected, not necessarily the second one. But that is now exactly the thing we could discuss. Because you could also make the argument that a function named connect database indeed might also take care about the error handling if that connection failed. So you could argue that it's not unexpected that we don't just connect to the database, but that we also show an error message if that connection fails. Because connecting to a database does not just include the success case, but also the failure case. That is an argument you could definitely make, and then having this other side effect would not be unexpected. You could, however, also argue that the only thing which is expected is indeed that the database connection is established, and nothing else. If that's the case, you could solve this problem by simply creating a new function, which you could call init app, so a function which is called at the beginning to initialize your app, and in there you call connect database, and you expect to get back a success value, let's say, and then you grab your console log message here, and you check if it's not a success here, in which case your initialization ends and you just show this error message, and otherwise you continue with other initialization steps which you might have. And in connect database, we therefore just return did connect, which could be a true-false value, originally returned by connect, which then is in the end checked here. This is something you could do. Now you could argue whether we really need a separate connect database function then, since that's in the end just renaming the operation we're doing in there. But it could be the case that we are doing more. For example, we could be preparing the connection URI, and we could be doing work here. So ultimately, if we do more work, having this separate function could make sense. If we really just call database connect, then indeed we just rephrased the operation, and hence extracting this extra function might actually not be a good idea. And we should have went with the init app function right from the start. And I'm just discussing all these different options to also make it clear that clean code always is something which depends on personal preferences and the general context, and it's something you can argue about. And that is important. There is no single right or wrong solution. But my goal with this course is to show you many potential factors which you should take into consideration and many potential strategies you can use to derive and write cleaner code. And therefore this here is now my solution for this first example. As you can tell by the discussion we had here, definitely not the only solution, but now a solution where I would argue that all the side effects are not unexpected and where therefore we did write some clean code. So let's now move on to the next function, determine support agent. Here we're getting a ticket, and then in the end we check the request type, which seems to be stored in the ticket, to either find a standard agent or an agent by request type. And then we return this agent. Now, does this function have any side effects? Well, it most likely does not. Maybe find standard agent and find agent by request type have side effects, but we wouldn't expect it if we just have a look at their names. I want to point out, however, that if these functions would, for example, send a HTTP request behind the scenes, or if we would establish some database connection inside of these functions, we would of course introduce a side effect. Just looking at the name of these functions, we shouldn't expect that they do either of that though, but it also always depends on the general context of your application, whether you could expect that they do something like this. For example, if you're building a browser-side web application or a mobile application, you could expect that a find something method or function does indeed send an HTTP request to a backend server. And then we would all of a sudden have a side effect here. But if we don't have that context, if we just have a look at their names, we probably shouldn't expect a side effect to occur here. So therefore this function doesn't have any side effects. It does not change the state of our system or any other state. Now what about this last example, is valid? Here we get two parameters and we validate this, show this message and then return false or true. This function clearly has a side effect and it is an unexpected one. If a function is named isValid, we expect to get back true or false. And of course we do, but we expect nothing more than that. We don't expect that anything else happens. And here we are also logging this message to the console, which is more than just returning true or false. This is a side effect because it changes our system state and it's an unexpected one as well. So this is not good code. The better solution here, of course, would be to take this code and create a new function, create user, for example, as we had it before, where we get our email and password. And in this function, we then call if is valid email password. And if that's not the case, we console log that, and otherwise we continue. Now create user is a function where this side effect could be expected, because validation and handling validation errors, that sounds like a task which is involved in the user creation process. But now isValid is a clean function because it does not have any side effects. Indeed, this is now a pure function because for the same email and password values, it will always return the exact same response values. To conclude this module, we'll have a look at another very important aspect, and that would be testing, specifically unit testing. Of course, you should be testing your code. So that means you should be running automated tests, and it would be even better if you would write your code in a test-driven way. This course is not about testing or test-driven development though. But unit testing will indeed help you not just with writing error-free code, but also with writing clean code. Because there's one simple question which you automatically have to answer when you utilize testing. Can you easily test a function? If the answer to this is yes, if you're not having any problems with side effects like data being written to a database, which you typically don't want during testing, and if you don't do 10 different things in one function, which are then therefore difficult to test, then it's great and you probably have clean code. If the answer is no, though, if you find that one function does too many things and you therefore have to write many tests testing different things for one and the same function, or if you have a lot of side effects in there, then you might want to consider splitting up your function so that you have multiple functions which are then easier to test. And that is how unit testing will help you write cleaner code and especially will help you write slim and focused functions. Because it turns out that small functions, which only do one thing and which don't have unexpected side effects, are way easier to test than big functions. Now, as an example, here's another dummy function, addProduct. It's validating some input, showing an error message, and then creating and storing a product. And therefore, of course, it's very similar to the createUser example you saw earlier in this module. Now, obviously, we can immediately see by now that we have mixed levels of abstraction here, and that the distance between the level of abstraction of the function name and the level of abstraction of certain steps in that function is too big. But even if we wouldn't see that, we would face problems when we try to write tests for this function. Here are two dummy tests as we could write them in JavaScript, for example. And of course, no matter which programming language you use, your tests will look something like this. I got two test cases here, and in the first case, I test whether the overall creation of the product works. In the second case, I'm actually only interested in the ID, and I want to find out if the ID was generated correctly. Because it turns out that my ID should be composed of both the name of the product as well as some random number which is converted to a string. Now, when writing these tests, I can see and feel that something's wrong with my addProduct function. Because for one, we have an unwanted side effect, not an unexpected one, but an unwanted one during testing. We are writing a product to the database. In addition, if I'm just interested in testing whether the ID was created correctly, I still have to run the entire addProduct function, including that unwanted side effect, just to then find out whether the ID was generated correctly or not. So therefore, this clearly signals to us that something's wrong with the function. We could test more, for example, if validation fails. For that, we would need to check whether this function completes successfully or not. And all these tests would run on the same function, testing totally different things. So clearly, this is not a great function. We should split it up so that we have multiple functions which are then easier to test. This is how we could refactor this addProduct function to be cleaner. It's way shorter and it's split up into multiple smaller pieces. I have the validateProductData function, which throws an error if we have invalid input, and even that is split up further into the inputIsValid function and then the reusable isEmpty and hasMinValue functions here. And the advantage of this is that I now, for example, can write tests which only test the isEmpty function. So I can only test this small unit now, and I can test parts of my validation, or also the entire validation if I wanted to, without running the entire addProduct function. I can also test just the generation of an ID if I wanted to, because I did extract an extra function for this. So I could check whether an ID is generated correctly without creating an entire product and storing that product in some database. And that is why unit testing helps you with writing cleaner code. You could derive this code without unit testing as well. But when writing tests and when testing everything, which I don't do in this solution, I just have some examples here, but when testing everything, you will automatically see what should be extracted and what should not be extracted. Because you want to extract as much as possible to write as many tests as possible, as long as they make some sense, of course. Now we don't need to write any unit test for add product. We could write an integration test for this, but we do have all these unit tests which we can write for the small extracted functions we have here. That's why testing matters, not just for avoiding errors and bugs, but also for writing clean code.